Okay, and then students then worked on the practice set. So just a few in particular that I want to look at. So if you're going through the practice set, pause the video. I'm going to keep going in 3, 2, and 1. All right, so here we have u times v all over 4. We want to get the factors and the coefficients. So what we see here is this can also be written as 1/4 all times u all times v. So therefore we see that these are the factors, whereas 1/4, that's going to be the coefficient. Another one I want to look at, g. So we see we got 8v minus 17yz plus 63b over 4gh. Remember, addition and subtraction, that is what is going to separate different terms. So we see here 8v and then minus 17yz, so this is a term, and then plus 63b all over 4gh, so that's going to be the last term. So here we have 3 total terms. I'm just going to write 3 terms. All right, looking down here, we see 4 plus 2x, but it's in parentheses. So going back to our last slide, we remember that 3 minus x, that's one term, it's in parentheses. So here, this all is going to be one term. So this whole thing is one term. And then plus 18s minus 47jkl. So here, we also have 3 terms. All right, so understanding variables and expressions. Again, we identified variables, expressions, and constants. All right, so here we're going to skip this. That was the homework that we had skipped today. All right, simplifying expressions using the product property of exponents, lesson 3, algebra 1. So you will be able to simplify exponential expressions. All right, so base, exponent, power. So here, the big number, we have our base. And then here, 3, that's going to be our exponent. So we can say this in a multitude of ways. We can say 5 to the 3, or pardon me, 5 to the third, 5 to the 3, 5 to the third power, 5 to the power of 3. So there's numerous ways that we can say this. And what this means is the following. The exponent tells the base, all right, base, you're going to multiply yourself by yourself this many times. So therefore we got 5, all times 5, all times 5. So again, we can use the exponent term, the power term, almost interchangeably. 5 to the 3, 5 to the third power, 5 cubed. There are numerous ways that we can say this, but at the end of the day, it just means the base is going to multiply itself by itself however many times the exponent says so. All right, so simplifying the expression. So if you want to go ahead and practice these on your own, I'm going to resume the vid. I'm going to resume in 3, in 2, and in 1. All right, one I really just wanted to go over together was this. So we have 1/2, all times 1/2, all times 1/2, all times 1/2, all times 1/2. And I like to count. All right, I got 1, 2, 3, 4, 5 total, exactly as the exponent told the base 1/2 to do so. So we get 1 times 1 times 1 times 1 times 1. Remember, multiplying fractions, multiply the top all the way across. So we just get 1, multiply the bottom all the way across. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So here we get 1 over 32, 1/32. I'm going to keep moving. All right, rules of exponents. We had 2 main rules. The first one, multiplying powers with the same base. The key thing that we do here is we're going to add the exponents. So that's really important. So we're going to wait on this second rule for just a moment. But here we see that x is multiplied. X is the base in every single term here. And they're going to be multiplied together. So x to the 5th times x to the 7th, all times x squared. And pardon me, x is the base just in every one that we see here. So here we're going to get, so again, we're going to add the exponents. So 5, all plus 7, all plus 2. So then we're going to get 14. And so we got x to the 14th. And that'll be our answer. Here, very careful, we have a as a base, but we also have n as a base. So therefore what we need to do is let's add up the exponents for a. So we have 3, all plus 2, all plus 4. That's going to give us 9. And then 6 plus 7 is going to give us 13. So therefore we have a to the 9, all plus n to the 13. So that's going to be our final answer. But wait a minute. What we see here is, was there a plus sign at all anywhere here? So this is an easy mistake to make. Let's make sure that there's no plus sign there. This is going to be multiplied. we see multiplication in here the whole time, so we need to make sure that it's always multiplied. All right, so again, easy fix. That's why we use an eraser in math. 8 to the 9th, all times n to the 13th is our final answer. All right, so let's go on to the second rule of exponents. Dividing powers with the same base. So we got to subtract the bottom exponent from the top exponent. Here, the bottom one doesn't have an exponent, or does it? Remember, if it's just, if there's nothing written there, it's just implied that it's 1. So therefore, we got 3 minus 1. That's going to give us 2. So therefore, what we see here is a cubed all over a is going to be a squared. All right, looking at the example on the right, we have 4 all minus 13. That's going to give us negative 9. So therefore, this is going to be b to the negative 9. And then the story that you've heard is that if you're naughty, you have to go downstairs and you become more positive. So if you're negative and naughty up top, you have to go down to the basement and you become more positive. So therefore, we get 1 all over b to the 9th. Okay? All right. So this example, we didn't have a chance to go over in class. So here, what we're going to do, so let me just remove this blinder here. All right. So I am going to go ahead and read this question. So a supercomputer topped out at 1 pflop. So I'm just going to say pflop is for p, just to make it simple. 1 pflop was equal to 10 to the 3rd tflops. I'm just going to say tflops. I'm just going to use the letter t to represent it. And then each tflop is equal to 10 to the 12th flops. So therefore, flops I'm just going to say is f. So what was the computer's speed in flops? So the first part of the problem-solving process that we're going to work on is we need to find out what are we looking for. We can see here we're looking for the speed in flops. So therefore, that's what we're trying to solve at the end of the day. What we do know is a supercomputer topped out at 1 pflops. So we're at 1 p, and then if you remember just from the past, if let's say we have like 2x over x, we know that x cancels and we're just going to be left with 2. So the same idea applies here. We're just going to try and get rid of the units that we don't want and be left with a unit of flops. All right, so going back to our example, we were told that 1 pflops was equal to 10 to the 3rd tflops. So therefore, 1 pflop all over, 1 pflop is going to be equal to 10 to the 3rd tflops. So therefore, if we're multiplying this across, p is going to cancel. Those pflops cancel. All right, and now I'm going to multiply another. I'm going to multiply one more time to get rid of the tflops. So therefore, we see here that each tflop, so therefore we see 1t, and again I'm putting t down below just to get rid of the t's, is going to be equal to 10 to the 12th flops. So what we see here is the tflops cancel, and we're left with just flops, exactly what we wanted. So therefore, we're just going to multiply, again, multiplying fractions, multiply across the top, and then divide anything, and multiply across the bottom. In this case, there's nothing there, it's just 1, so it'll just be 1. So what we see is we get 10 cubed, all times 10 to the 12th is going to be equal to 10 to the 15th flops. So that is for our first question here. So we get 10 to the 15 flops. Okay. Looking at our second example, I'm going to go ahead and erase this and look at our second example. So this process here is called dimensional analysis. It's really applicable here in these types of questions, and especially in science, like thinking about unit conversion chemistry. So let's read this next question. So there are 10 to the 6 exabytes, so I'm just going to write E for exabyte, so it's easy, so I don't have to write exabyte, in a yottabyte. All right, so again, Y for yottabyte. There are 10 to the 9 gigabytes in an exabyte. So how many gigabytes are in a yottabyte? So we want to say question mark, what are we looking for? We're looking for gigabytes equals 1 yottabyte. All right, so we want yottabytes to cancel. So now let's go ahead and get rid of yottabytes. So let's see. So in 1 yottabyte, we see from the first sentence, there's going to be 10 to the 6 exabytes. All right, and again, we're trying to get gigabytes. So it looks like the yottabytes are going to cancel now. But now let's see if we can get rid of exabytes and replace that with gigabytes. All right, and then here it says there are 10 to the 9th gigabytes in an exabyte. So therefore, in 1 exabyte, there's 10 to the 9th gigabytes. So therefore, we see Yottabytes cancel, exabytes cancel, and we're left with gigabytes. So 10 to the 6 times 10 to the 9, same base. We add the exponents. 6 plus 9 is going to give us 15. So 10 to the 15 gigabytes in 1 yottabyte. All right, this was your practice set. So yes, I really recommend especially practicing this one now. And then again, today we did simplifying expressions using the product property of exponents. Again, you'll be able to simplify exponential expressions. There is the answer to the lesson practice there, the practice set. And then the homework was lesson 3, number 7 through 10, 18, 21, 23 through 27, 29, and 30. 22, that was the one that we just did with the dimensional analysis. Thank you so much. Have a great day.